Welcome to this special two-part training session about the Screaming Eagle, the new 1990 Eagle Talon. This is the first of two programs which will introduce to you the highlights and service features of this sleek sports coupe. In part one, we'll look the Talon over from top to bottom, so you'll be familiar with it when it comes into your dealership for service. Then we'll cover the Talon powertrain in more detail, including engines, turbocharger operation, and service highlights and transaxles. Part two of our special training session on the Talon will cover Talon's all-wheel drive transfer case, the four-wheel disc brakes, the suspension systems, and the electronics. Be sure to watch both of these training sessions so you can stay on top of the latest Eagle technology. Eagle's brand new three-door sports coupe for 1990, the Talon, is available in three models: the Talon TSI, and the Talon TSI all-wheel drive. The TSI designation stands for Turbo Sport Intercooled. The front-wheel drive base Talon is equipped with a 2-liter 16-valve dual overhead cam naturally aspirated engine. The Talon TSI is front-wheel drive with a 2-liter dual overhead cam 16-valve intercooled turbocharged engine. And the Talon TSI all-wheel drive has the same intercooled turbocharged engine as the Talon TSI, plus full-time all-wheel drive for a sure grip on the road. The base Talon with the 2-liter dual overhead cam 16-valve engine comes standard with a 5-speed manual transaxle. A 4-speed automatic transaxle is optional. Both the front-wheel drive Talon TSI and the all-wheel drive Talon TSI have a 5-speed manual transaxle mated to their 2-liter intercooled turbocharged engines for 1990. Now, let's take a first-hand look at the all-wheel drive Talon. The Talon will stand out instantly in your rearview mirror before it soars past you. The sleek shape of the two Talon TSI models gives them a drag coefficient of 0.29. The power dome in the hood indicates the Talon's engine's dual overhead cam configuration. All Talons have retractable halogen headlights. The bumpers are made integral with the body. The intercooler duct on both TSI models is located in the air scoop on the passenger side of the car. 16-inch polycast sport-style wheels are standard on all Talon models, while 16-inch alloy 5-spoke turbine-style performance wheels are optional on TSI models. Both TSI models have P205/55 VR16 steel-belted V-speed-rated all-season performance tires as standard equipment, while the base Talon comes equipped with P205/55 HR16 steel-belted radials. All 1990 Talon models have McPherson strut-type suspension systems. Each model's front suspension system includes negative offset geometry for good handling under all driving conditions, anti-dive geometry that reduces the car's tendency to nosedive under hard braking conditions, and offset coil springs for riding comfort. The all-wheel drive model's front suspension has two separate cross members that are connected by left and right members. Meanwhile, the front-wheel drive models have only a single crossmember located directly over the front axle. We'll go into more detail about the front suspension systems in part two. The Talon's brake system matches its superb driving performance. All models are equipped with a diagonally split four-wheel disc brake system. The front discs are vented, while the rear discs are solid. In part two, we'll look at the brake system in more detail. And moving to the rear of the car, this rear suspension design, which features a fully independent wishbone design, is unique to the all-wheel drive model. Both camber and toe can be adjusted on this new suspension. The rear axle has a viscous coupling limited slip differential, which reduces slipping of the rear wheels for better performance on a rough road or slippery surface. The propeller shaft on the all-wheel drive Talon has 3 sections, 4 joints, and 2 center bearings. The 3-piece shaft is designed to reduce noise and vibration during high-speed driving. Cross universal joints are used at joint numbers 1, 2, and 4 of the propeller shaft. A lowbrow joint is used at joint number 3. All of these features gently reduce the torque variations and the vibration and noise level. The all-wheel drive system on the Talon uses the W5M33 transaxle with integral transfer case with center viscous coupling. In Part 2, we'll talk more about the transfer case and the center viscous coupling operation and service highlights. All Talons have a fuel capacity of 15.8 gallons. The gas tank location on the all-wheel drive model is located beneath the trunk floor. The floor of the tire well is approximately 5.9 inches higher than the front-wheel drive models to accommodate the rear axle. On front-wheel drive models, you'll find the fuel tank below the rear seat floor. The all-wheel drive Talon's exhaust routing also varies from the front-wheel drive models. The Talon TSI all-wheel drive has 5 more horsepower than the Talon TSI because of the modified exhaust system. There are many standard features on the Talon. Some of the standard features include a tilt steering wheel, powered dual remote control mirrors, a front 2-point motorized passive restraint system, just to name a few items. The available options are air conditioning, alloy turbine wheels, electronic cruise control, liftgate wiper washer, power windows, and a security alarm on the TSI all-wheel drive. We'll cover how the alarm system works in Part 2. Now let's take a look inside the cockpit. The wraparound instrument panel makes all the controls and gauges easy for the driver to reach and see. On the left side of the instrument cluster is a button to raise the retractable headlamps. This button raises or lowers the headlights but does not turn them on. Beneath this button is a switch for turning the headlights up and on. The analog gauge instrument cluster includes the tachometer, the turbo boost gauge, the engine temperature gauge, the oil pressure gauge, the fuel gauge, the 145 mile/hour speedometer, and the trip odometer. To the right of the instrument cluster is the hazard warning button, electric window defroster, and a rocker switch for the optional rear wiper washer. Other symbols and warning lights include high beam, turn signal indicators, cruise control on indicator, check engine warning light, low coolant symbol, brake hydraulic system failure, parking brake warning light, door ajar symbol, low fuel light, overdrive off indicator, which is on automatic transaxles only, and a seatbelt reminder symbol. The left stalk controls the headlights and the turn signals. Pulling the lever towards you operates the flash to pass feature. When the headlights are on, the beam will switch from low to high, and when the headlights are off, the optical horn is switched on. On the right-hand stalk are the windshield wiper controls and the cruise control. There are 4 rotary climate control knobs on all Talons. Here's the fan switch, the temperature control knob, the control which allows you to select the direction of the air, and this one over here allows you to select outside or recirculated air. The control for the optional air conditioning is located here. This control is a 2-step AC switch. Press the switch once and the air conditioner will be in the economy mode. In this mode, the compressor only operates on demand. Press the switch again and the air conditioner will be in the normal mode, meaning the compressor will operate continuously. The remote fuel filler door and liftgate releases are located on the floor next to the driver's door. The hood latch is within easy reach on the left side of the instrument panel. All Talons have sporty front bucket seats, while the TSI model's driver's seat has 6 adjustment points. The TSI all-wheel drive models have split folding rear seats, while the other models have a folding rear seat back. Before we wrap up our overview of the Eagle Talon, there are a couple of items you should remember when you're prepping these new vehicles for your customers. Recently, a hotline newsletter was issued about the installation of rear tie-down hole plugs. These plugs, located in the bottom lower sill of the left and right wheel area, cannot be installed at the assembly plant. Therefore, these plugs must be installed during new car prep. The plugs have been placed in the glove box. Install the plugs by hand, making sure they are fully seated and locked in place. Also, remember to plug in fuse number 4, which has been removed to prevent excessive drain on the car's battery. This fuse must be installed before the car is delivered to the customer. Now that you've gotten a quick look at the Talon, let's take a closer look at the power plants that propel the Screaming Eagle. There are two engines available on the Talon. The base engine is a 2.0-liter sequential multi-point electronic fuel-injected 16-valve dual overhead cam 4-cylinder engine. Bolt on a water-cooled turbocharger, an air-to-air intercooler, and the additional inputs and outputs for the turbo fuel control system, and you've got the screamer that goes into the TSI models. Let's take a look at the 2.0-liter naturally aspirated engine first. The 2.0-liter 16-valve dual overhead cam MPI engine delivers excellent power and performance. High power output is derived from the cross-flow head design, featuring 4 valves per cylinder, while dual overhead cams allow maximum cylinder head efficiency. Twin balance shafts help ensure smooth performance as noise and vibration are reduced. Responsive fuel metering is provided by the multi-point fuel injection system. It all adds up to the performance capabilities of a full 135 horsepower at 6,000 RPM and 125 pounds-feet of torque at 5,000 RPM. Now let's take a look at the intercooled turbocharged 2.0-liter engine. This engine delivers amazing power for its size. The low-inertia turbocharger provides quick throttle response. Special wide-range fuel injectors precisely feed each cylinder, while premium alloy pistons help ensure durability. And an intercooler allows a denser fuel-air mixture to be burned for optimum output. Specifically, this intercooled turbocharged 2.0-liter engine delivers 190 horsepower at 6,000 RPM. Note 195 horsepower at 6,000 RPM for the Talon all-wheel drive, and 203 pounds-feet of torque at 5,000 RPM. Impressive performance is assured. Both the naturally aspirated and the intercooled turbocharged 2.0-liter engines have a 3.35-inch cylinder bore and a 3.46-inch stroke. They also share the same firing order, 1-3-4-2. The compression ratio of the naturally aspirated engine is 9.0 to 1, while the compression ratio of the turbocharged engine is 7.8 to 1. The fuel pressure for the naturally aspirated 2.0-liter engine is 47.6 psi, while the fuel pressure for the turbo 2.0-liter engine is 36.3 psi. Here are the fuel injectors for both engines. The injectors for the naturally aspirated and turbo engines must not be interchanged because each has a different resistance. The resistance of the 2.0-liter injector ranges from 13 to 16 ohms, and the resistance of the 2.0-liter turbo injector ranges from 2 to 3 ohms. The number 1 cylinder on both engines is located at the vibration damper end, the driver's side of the engine compartment. Both 2.0-liter engines share a distributorless ignition system similar to the Eagle Summit's 1.6-liter engine. The 1.6-liter system was discussed in the June 1988 VideoTec release. The 2.0-liter Talon and Summit 1.6-liter engines use similar crankshaft angle sensors on the aft end of the intake camshaft. Their service procedures are identical. The 2.0-liter turbocharged intercooled engine has additional inputs and outputs for the fuel control system. Let's take a look at those on the engine. The inputs and outputs for the turbo fuel control system are the turbo meter or turbo boost gauge. Displays the boost pressure by means of a boost gauge in the instrument panel. The boost pressure is determined by the duty ratio or engine load. As the duty ratio calculated by the ECU increases, the average flow of current to the turbo meter also increases, and the turbo meter indicates a higher value. As engine load decreases, the turbo meter indicates a smaller value. The detonation sensor, which is mounted on the engine block, signals the ECU to retard the timing when engine knock is present. The turbo engine has a different airflow sensor from the naturally aspirated engine. These sensors must not be interchanged. The turbo airflow sensor has a reset filter which lessens turbo noise during deceleration or when the idle speed switch is on or the TPS voltage is low. The fuel pressure control valve is located next to the purge control solenoid valve. The fuel pressure control valve will increase the fuel pressure, for example, under such conditions as a hot restart or during high-speed, high-low driving. And the wastegate solenoid valve, which receives instructions from the ECU and controls the wastegate actuator, is located behind the turbocharger housing. Now that you're aware of some of the basic differences between the 2.0-liter engines, let's take a look at how the turbocharger works. A turbocharger is a very simple yet effective way to increase an engine's performance. Turbocharging compresses the intake air and forces it into the cylinders, making a denser air-fuel mixture. More air and more fuel means more horsepower, a necessary ingredient in today's marketplace. The main elements of all turbochargers are the turbine and the compressor wheel, securely attached together by a shaft. The exhaust gas causes the exhaust wheel to spin, which in turn rotates the compressor wheel, forcing compressed air into the cylinders. The pressure of this air is controlled by a wastegate. If this boost pressure exceeds the preset factory limit, the wastegate will reduce the exhaust gas around the turbine, slowing the compressor wheel. The TALON's turbocharger, like most turbochargers used in the field today, is water-cooled, meaning that engine coolant flows through the turbine housing to help remove some of the extreme heat the turbo generates. Temperatures on the compressor side of the turbo average between 350 to 400 degrees Fahrenheit, while the turbine side can reach between 1200 to 1500 degrees Fahrenheit. Removing some of the heat helps prevent the breakdown of engine oil and increases the durability of the turbocharger. It is also important to note that tolerances as close as 1/1,000,000th of an inch are used in assembling the turbo's internal workings, and the turbo's wheels can operate at speeds between 20,000 and over 100,000 RPMs. It's important to emphasize to owners that they must follow the maintenance schedule. Because of the turbo's strict tolerances, the turbo's high operating speeds, and the turbo's ability to generate extreme heat. Now here's where the intercooler comes into play. The intercooler cools the hot compressed air from the turbocharger before it enters the intake manifold. The intercooler works as it receives outside air from the air scoop as the car moves forward. The hot compressed air from the turbocharger flows through the intercooler channels, which are cooled by the outside air. The now cooler compressed air is sent to the intake manifold. The water-cooled turbo used on the TALON is serviceable. It has a replaceable cartridge which houses the compressor and exhaust wheels and their rotating shaft. Therefore, you may not have to replace the entire unit. Should you have to replace a turbo cartridge, here is how you do it. After you have removed and disassembled the turbocharger according to the TALON service manual, with the compressor cover facing downward, remove the snap ring using a pair of snap ring pliers. Tap the compressor cover with a soft-faced hammer to separate the turbine cartridge from the compressor housing. Coat the inner surface of the new O-ring with a thin film of engine oil and set it in the groove of the cartridge assembly. To install the cartridge in the assembly, install the cartridge cover by aligning the dowel pin. Next, place the compressor cover face down and install the snap ring. After the snap ring is installed, while being careful not to damage the blades of the turbine wheel, install the cartridge on the turbine housing. Make sure you have installed the turbine housing in the right direction. Continue to install the turbocharger according to the service manual procedure. Now let's take a look at the other half of the powertrain, more specifically the transaxle lineup. As we already briefly mentioned, the TALON has 3 transaxles available. There's an optional 4-speed automatic on the base TALON. Both TSI models have standard 5-speed manual transaxles. The optional 4-speed automatic transaxle used on the Talon is similar to the one used on the Eagle Summit. It might be a good idea to take a look at the February 1989 VideoTec, which covered the 4-speed automatic transaxle. However, before we examine the features of this transaxle, you should know the location of the transmission identification tags. Now, this new identification tag is located underneath the car on the transmission case. Here's where the tag is located on the TALON TSI all-wheel drive W5M33 transmission. The overdrive lockout switch is identical in function, but different in appearance from the switch used in the Summit. This next feature is not available on the 1989 Summit. The power economy switch, located on the center console, provides a choice of 2 shift schedules, which are stored in the Transaxle Control Unit, or TCU. The AT safety lock system on the Talon is designed to prevent a sudden start caused by the automatic transaxle malfunctioning. Unless the brake pedal is depressed, the shift lever cannot be shifted from park to any other position. When the ignition key is in the lock position or is removed from the lock, the shift lever cannot be moved from park. The automatic transaxle sensors and relays are the same as those used on the Summit, but they might be in a different location. The Transaxle Control Unit is located under and behind the instrument center panel. That's the same place it's located in the Summit. And like the Eagle Summit, the Talon's Transaxle Control Unit shares some of the same sensors the engine control unit uses. The Talon's throttle position sensor is attached to the throttle spindle, just like the Eagle Summits. The vehicle speed read switch is located behind the speedometer. The inhibitor switch is mounted with the shift lever on the transaxle housing. Engine RPM is input to the TCU from the crank angle sensor, which is mounted to the rear of the cylinder head. The solenoid valves are on the valve body. The oil temperature sensor is located under the valve body. In Part 2, we'll take another look at the Talon and explore the transfer case with the viscous coupling, the suspension systems, the electrical and interior features, and diagnostics. Make sure you have a good look at both releases so you'll be able to stay right on top of the brand new Eagle Talon when one pulls into your dealership for service. In the second part of this 2-part training session, we're going to continue covering new model highlights of the 1990 Eagle Talon. In the first part, we covered the overall model lineup and some of the unique features of this new vehicle. We also looked at the available engines and transaxles. In this part, I'm going to finish up with the powertrain components by talking about the center differential used only on the Talon all-wheel drive model. Then we'll cover suspension systems, brakes, electrical features, and diagnosis with the DRB2. The key to Talon's optional full-time all-wheel drive is this center differential. It has a viscous coupling that automatically responds to differences in rotation speed between the front and rear axles. The viscous coupling uses a special silicone oil whose viscosity or thickness is more resistant to temperature changes than normal oil. As this simplified diagram shows, the special oil separates 2 sets of plates which move in relation to the front and rear axles respectively. In a situation like this, where one wheel is slipping on the front axle, the plates attached to that axle will be moving, while the plates attached to the other axle won't. The fluid next to the moving plate moves at the same speed as the plate, while that next to the stationary plate tends to stay still. Because the fluid is thick, it has a great deal of resistance, and tries to equalize the movement of the plates and the attached axles. The end result is that less torque is sent to the slipping or moving axle, and more goes to the one with good traction. During normal driving on dry roads at a constant speed, the center differential equally distributes the power between the two axles. Because there is no rotational speed difference in the viscous coupling, it has no effect on the action of the differential. When accelerating or starting out, inertia causes the center of gravity to shift rearward, and the center differential causes less power to be transmitted to the rear axle. However, the viscous coupling reacts to the rotational speed difference between the front and rear axles and ensures equal power distribution. When one or both wheels slips on either the front or rear axle, it creates a large difference in rotational speed between the axles. The difference in rotational speed within the viscous coupling causes a large differential torque to be applied, sending more power to the wheels that have good traction. While the viscous coupling itself is serviced by replacement only, the center differential can be serviced. We won't cover the entire disassembly and reassembly procedure here, but you should be aware of a few important points. These are the major components of the center differential or transfer case: the extension housing assembly, the transfer case adapter subassembly, and the transfer case subassembly. To service the Talon's transfer case, you'll need these tools: a dial indicator, a torque wrench, and the special transfer case tools, including a gear puller, this special spanner, this wrench adapter, the side gear holding tool, a 3/8 inch to 1/2 inch drive adapter, and these oil seal installers. During reassembly of the center differential transfer case, there are several items that must be checked and adjusted if necessary. For example, the turning drive torque of the driven bevel gear must be within specs before the transfer case adapter subassembly is installed. Likewise, the turning drive torque of the drive bevel gear must be checked and adjusted if necessary before the transfer case subassembly is reinstalled. The final check is for proper contact of the driven bevel gear teeth. To make this check, you must lightly brush a thin coat of machine blue of minium to both tooth surfaces of the driven bevel gear before installing the transfer case adapter subassembly. Then, with the transfer case assembled using special tools MB990988 and MB990326, turn the drive bevel gear shaft one turn in each direction, both normal and reverse rotation. It's important not to rotate the shaft more than one turn, or you could blur the tooth contact pattern. This is the proper tooth contact pattern. This is the small end of the gear. This is the large end of the gear. This is the surface that receives force in forward motion. And this is the surface that receives force in reverse motion. If the tooth contact pattern is incorrect, you must adjust by replacing one or more of the following selectable spacers: the spacer for adjusting the driven bevel gear mount, the spacer for adjusting the drive bevel gear preload, the spacer for adjusting the drive bevel gear mount, or the spacer for adjusting the driven bevel gear preload. You'll find complete disassembly and reassembly procedures, including all torque and clearance specifications, in the 1990 Talon Service Manual. All 1990 Talon models have McPherson strut-type front suspension systems. The struts themselves are serviced by replacement only. 3 different coil springs with different dimensions and ratings are used on the various models. The springs are color-coded for easy identification and should not be interchanged. If you replace a spring, make sure you use a replacement with the same color code marking. For example, the front springs on this 1990 Talon TSI AWD are identified by this pink marking. Two different rear suspension designs are used for the Talon. All two-wheel drive models use the same trailing arm 3-link suspension design shown here. Its simple design makes it light in weight and easy to service. The rear suspension for the all-wheel drive version of the Talon is unique. It's a fully independent double wishbone design that features toe-in correction and provides a combination of excellent steering stability with a comfortable ride. It also includes a second viscous coupling, which makes the 1990 Talon one of the few vehicles to use two separate viscous couplings in its powertrain design. This rear viscous coupling works on the same principle as the one in the center differential and provides good traction to both rear wheels under all driving conditions. The viscous coupling itself is serviced by replacement only. Another feature of this rear suspension is that both camber and toe can be adjusted. The toe adjustment is made by turning this eccentric bolt that attaches the trailing arm to the crossmember. Turning the bolt rearward moves the toe out, and turning it forward moves it in. Camber is adjusted by turning the eccentric bolt that attaches the upper arm to the crossmember. Turning the bolt inward increases positive camber. Turning it outward increases negative camber. For specific information on toe and camber adjustment, refer to the 1990 Eagle Talon Service Manual and the operating instructions that came with your dealership's alignment equipment. All Talon models have a diagonally split four-wheel disc brake system. The power-assisted four-wheel disc brake system provides impressive braking capabilities in all types of driving conditions. The front brakes have vented discs, and the rear brakes have solid discs. The vented design helps dissipate heat more rapidly at the heavily loaded front brakes. Semi-metallic linings provide superior fade resistance, and a specially engineered dual proportioning valve delivers optimum front and rear balance for sure straight stops in all types of driving conditions. A dual diagonal hydraulic system assures safe front and rear braking in the event of partial hydraulic pressure loss. For the most part, service of the four-wheel disc brake system is similar to service of other brake systems. The system's dual proportioning valve is serviced by replacement only, but there is a procedure for checking its operation. To test the proportioning valve, first connect pressure gauges to the input and output sides of the valve. Then air bleed both the pressure gauges and the brake line. While slowly depressing the brake pedal, make the following measurements. The split point, or point at which output pressure begins to drop relative to the input pressure, should be between 562 and 633 psi. When input pressure is at 1166 psi, the output pressure should be between 732 and 804 psi. Finally, the difference between the left and right brake lines should be 57 psi or less. If any of these measurements is out of spec, you should replace the proportioning valve. There is an adjustment you can perform on the parking brake lever with this four-wheel disc brake system. Pull the parking brake lever at least 5 and no more than 7 notches. This should be enough to set the parking brakes and hold the car. If it is not within specifications, you'll have to adjust the parking brakes following the procedure in the service manual. The parking brake cable adjusting nut is located here, under the carpeting in the floor console. Talon has a number of electrical features, both standard and optional, that may be new to you. For example, there's an optional theft alarm system. Once activated, it will sound the horns and flash the optical horn for about 3 minutes if the hood, liftgate, or doors are forced open. At the same time, the starter circuit is disabled so that the engine can't be started without the ignition key. Here are the components of the theft alarm system. The system is controlled by a separate microprocessor that is part of the ECU. It arms, disarms, activates, and deactivates the system. The headlight relay, horn relay, horns, and headlights are all part of the system to provide audible and visual signals. Switches that act as system inputs include the door key cylinder switches, the door lock actuator switches, the door switches, the hood switch, the liftgate switch, the liftgate lock switch, the clutch pedal switch, and the key reminder switch. The other system components are the starter relay, a special theft alarm starter relay, and the security light located on the instrument panel. Let's take a look at how the system actually works. To arm the system, all the driver has to do is follow the specified locking procedure. It begins when the key is removed from the ignition with both doors closed. Then all the driver has to do is lock the doors normally using either the key or the keyless locking method. The system is now set. The security light on the instrument panel will light for about 20 seconds and then go out. This indicates that the system is armed. Once the system is armed in this way, any attempt to enter the car without using the key to unlock the doors or any attempt to force the hood or liftgate will set off the alarm. You can check system operation by arming the system and then unlocking the door without the key and opening it. The horn should sound, and the optical horn should flash for about 3 minutes. The car cannot be started without the ignition key. Once the system is activated, you can disable it by simply using the key to unlock the door or liftgate. If the driver arms the system without leaving the car, it can be disarmed by simply putting the key into the ignition and turning it to the on or accessory position. Another interesting feature on the new Talon is the one-touch power window control. To lower the driver's side window, all the driver has to do is press and release the window switch. The window will then travel to the fully down position by itself. All Talon models also have pop-up headlights. Small electric motors are used to raise and lower the headlights. The relay for these motors is located here in the relay center under the hood on the passenger side of the engine compartment. Incidentally, the other relays located here include the power window relay, the alternator relay, the radiator fan motor relay, the fog light relay, the tail light relay, and the headlight relay. The AC compressor relay and the AC cutout relay are located here. If for any reason the system fails to operate and one or both headlights is stuck in the closed or down position, the headlights can be raised with these knobs. There is one located behind each headlight. Turning it clockwise will raise the headlight to the fully opened position. Like other Jeep and Eagle vehicles, including the Mitsubishi-built Summit, the 1990 Talon has self-diagnostics that can be accessed using the DRB2 tester. However, there are some differences. As you probably know from watching the June VideoTec session, you must use a special adapter and cartridge in testing the Eagle Summit. That session covered the use of this MMC adapter and special MMC cartridge. To perform diagnostics with the DRB2 on the Eagle Talon, you must use the same MMC adapter. However, there is a new cartridge for 1990 that works with all 1987 through 1990 Jeep and Eagle vehicles, 1989 and 1990 MMC vehicles, and the 1990 Talon from Diamond Star Motors. You must use this cartridge with the DRB2 to diagnose systems on the Talon. We don't have time to completely cover the use of this new cartridge, but you'll see that the menus and commands are like those for other Jeep and Eagle vehicles. It also provides new features and capabilities that you can use on all Jeep, Eagle, and MMC vehicles, as well as the Talon. The diagnostic connector on the Talon is located here by the driver's side kick panel. Once the DRB2 is hooked up, you can insert the 1990 Jeep Eagle cartridge. Make sure that you put it in label up, like this. The DRB2 will then go through its self-test. After it completes the self-test, the Chrysler motor's copyright message will be displayed for a few seconds, and then you'll see the DRB2 menu. If you are familiar with the use of the DRB2 on other Jeep and Eagle vehicles, you should have no trouble using it with the Talon. Begin by choosing the Select Vehicle option from the first menu. Then choosing the proper model, year, and equipment for the car you're testing. Once you've done that and confirmed your choices as correct, you can begin your diagnosis. Because Jeep and Eagle onboard diagnostics are somewhat different from MMC's, not all of the functions will work. For example, on MMC and Diamond Star vehicles, you can't perform automatic system tests like you can on Jeep vehicles and Eagle Premier. But you can use this new 1990 Jeep Eagle cartridge on all Jeep and Eagle vehicles that can be tested with the DRB2. So from now on, the DRB2 will basically work the same way with any Jeep or Eagle vehicle you're testing. This new cartridge also gives you some added test functions. For example, the feature called Custom Display allows you to choose as many as 4 different state displays to be shown on the screen at once. Here, the technician has chosen to see the map sensor reading, the TPS state, the coolant temperature, and the air temperature sensor readings. You can create 2 different custom displays and switch between them. This feature lets you see the relationship between several different sensor readings. You can use Custom Display to view current, static, or min current max readings. For additional information on using the DRB2 on any Jeep or Eagle vehicle, refer to the previous VideoTec release I've already mentioned, or to the appropriate diagnostic test procedures manual. Well, that wraps up our special training session in 2 parts on the 1990 Eagle Talon. We've covered a lot of technical highlights, including a number of features on this all-new sports coupe that may be new to you. Refer to the 1990 Talon Service Manual and other technical publications for more details.